Thank you. Now that was like an introduction. Wow. Let's see. I can fulfill all these things. Now, very exciting to be here. And do we have? Yes. Okay. Great. Very excited to be here, and it's awesome that so many people are here in this room. I was afraid that I will be the only one in the audio-video team in the back. By the way, awesome guys over there. 2 points why I thought that would be critical, that I will be the only one in this room, because I'm talking about hardware at kind of a software conference. And secondly, somehow I'm ending up at the slot right before lunch, always, right? So I have a habit of like mitigating that to keep your attention up. At the end of the talk, there will be a test, and you have to pass that one to receive lunch, right? So sharpen your pencils, take notes, and at the end, we'll see how you fare with my test. All right, so again, I'm Thilo. I'm working for Mercedes-Benz. We are a 100% subsidiary of Mercedes, Mercedes-Benz Tech Innovation I work with. So we're a 100% subsidiary of Mercedes-Benz, like with a history of over 25 years. We're located in Germany in a couple of cities, Ulm, Stuttgart, Karlsruhe, and Berlin. Have a group-wide network, also in Spain, Turkey, India, and Malaysia. And we do all sorts of things. We do customer data management. We do vertical function integration for car sales, and we do after-sales things, and we have focus on cross-cutting technologies like cybersecurity. We're a pretty stronghold of that. We are at the forefront of Gen AI for Mercedes. And open source also falls into this cross-tech category. So we are part of, as you heard, the Eclipse SDV Working Group for Mercedes. And then there is this column, which is just called Car, which is centered around developing software for cars, for our actual core product, basically. Offboard, like cloud services for connected cars and stuff, and but also embedded in onboard software, and that's where basically my home is in that organization. Yeah, so in this talk, what I'm going to share with you is some thoughts about software-defined vehicles. I know that's probably something that you all heard 100 times before. There's 2 or 3 things that I still want to say and share my thoughts with you. And then I'll try to make the case for why I think we need a hardware reference platform to make that work. And after like a theoretical kind of part, I'll have a concrete example how that could look like. And I'll close with some key takeaways. And I'll have a kicker thought at the end. So and remember it as the test, right? Let's dive right in. So the software-defined vehicles, right? At least at this conference, maybe before, you have heard it very often what that might be. And it's first up on the slide, right? It says software-first mindset. And I want to share with you one thing that I encountered. There's like a saying going around, like software eats Spaltmaß for breakfast, right? And I really want to debate that because it's not about the physical object that we call a car that has a sleek design, great haptics and stuff like that. Feels good if you sit in it and drive with it. Sounds fantastic. And Spaltmaß is part of that, right? And I'm totally not debating that. It's not about that. It's not about Spaltmaß at all. We just want to sell luxury cars with top-notch quality at Mercedes, right? And so Spaltmaß can't be traded off for anything, right? It's about the computerization, the computers that we have built into the car in the last decades, I guess. And when we started to put computers into the car, well, we had all this physical engineering going on, and we knew how to build physical things, and so I guess we concentrated on hardware first because that's what we could do, right? We were used to do. But in the end, it turns out that software is this thing that makes your car, right? We built 1 million of these physical objects. But we don't want you to think, I have one of those 1 million objects, right? We want to think that you own your car. It's your car. It's an individual thing. And that comes through personalization, right? The car knows you. It's like how you pick your friends out because they know you, right? And my car knows what music I like, right? Which ambient lighting I like. And it knows that when I'm leaving home for work, I always forget to turn the lights off in the house. So it checks for me, and for sure the lights are still on, and so it switches them off for me, right? So that's all the things that software can do. And there's another thing. So we talk about always fresh, right? We update our vehicles continuously. You can really do this only with software, at least efficiently, right? When I worked before at Intel, I learned why hardware is called hardware, because hardware is hard to change, right? That's not the case for software. Software is pretty easy to change. How we put the updates into the car is it's probably still a hard story, right? At least a not so easy story, as we heard yesterday, for example. But yeah, you can only do all these things with software, right? And that's what we have to keep in mind. And that's why we call it software-defined vehicle, right? So I wanted to talk about hardware, right? But yeah, so still I have another thing that's going on right now. The one paradigm shift is we're going from hardware engineering to software-first mindset, right? And try to work our way back to what this means for hardware. Second is we have put all these little computers into our cars, right? One for autonomous driving, one for connectivity, right? One for say, powertrain, charging, and stuff like that, body and comfort, and yet another for infotainment and stuff like that. Right? And now we have all these 5, 6, 7, 8 computers, ECUs in the car, and we started to build software for it. And so we built a software stack on the ADAS unit, we built a software stack on the connectivity unit, we built a software stack on the infotainment unit. And it turns out they all do more or less the same, but still are different, right? And we put work in all of these things. And of course, every OEM does it again differently in his house, right? So we have a multitude of stacks and stuff out there. And so what we're going to is to see more centralized architectures, more centralized computers in the vehicle. And therefore, we also need, so we are basically breaking up these functional boundaries, these functional domains that we have, and deploy stuff from different domains, functional domains, onto the same computer, right? And so now we are in the place where we have to somehow have a stack that supports all these functional domains all at once, right? And also that needs to become a platform, a core stack that can do all of this and has to have like a stable interface to the outside boundary somehow, so that you can have a stable development and for maybe generations, right? So, and on the other hand, it needs to run on different hardware options, right? And so hardware independence, decoupling from hardware, which is anyway the prime directive in software-defined vehicles, plays a key role here. So now, in the Eclipse SDV Working Group, in the Technical Advisory Committee, we have talked about how could that look like, and we tried to align on or build a common understanding about what the terminology is, what the things are, and we came up with a common understanding kind of a thing, and we drew a picture that you see up here, which is like our high-level architecture, right? And it's not surprising. It's like architecture in like buildings. It's like it has walls and a roof and a couple of windows and a door, and not surprising, but still was a good exercise to have to align everybody on what we want to do here. And then have a jumping off point where we say, okay, now we can go and fuel that with code somehow, because drawing pictures is fine, right? But somehow we need to have a tangible outcome somehow. And that is what this project will be, or aims to be, that it was referenced a couple of times, abbreviated with SCORE, S-Core, whatever, Safe Open Vehicle Core. And so check this out if you want to learn more about that. But yeah, so this is the attempt to fuel this idea here with code somehow. And so basically, what we're going to do is we are on our way to build this common software stack for SDVs. And surprisingly, actually not surprisingly, but this somehow needs to run on some computer, right? Software and hardware is always a symbiosis somehow. So if you have software, if you don't have a hardware to run it on, well, it's nothing, not worth anything, right? And vice versa. So obvious thought, right? The stack needs to run somewhere. Second obvious thought is, well, this is car software, so it's intended to be in the car, so it somehow needs, we need to have a hardware that integrates well with like a vehicle, right, a car. And then thirdly, we want to do this collaboratively. Right? Open source is fine. We can dump code into the open all day long, but if there's no collaboration, we've achieved nothing, basically, right? And so there needs to be people, organizations willing to work together, and I'm not saying collaboration is like we work on kind of the same topic and some of the people work over here and some of the other people working over there, and they are loosely coupled by the topic or something. No, we want to all unite them in the same place and all work together in the same, at the same thing, right? And that also means they are all standing on a common ground, basically. And so what would be a common ground for such an undertaking to build a core stack? Well, I guess that's a common hardware platform. So, in essence, these three things say basically we need a hardware platform that is capable to being put into the car and which enables us to build this converged stack to bring all these pieces and aspects that we have heard about at this conference and elsewhere, right? And kind of put it together. Maybe there's other aspects that need to be created from scratch. Excuse me, from scratch. And so, but it's a collaborative undertaking, and we need a common foundation for that. And and that's my call. Let's be that. Let it be a common hardware reference platform. So the vision really is we have something, a hardware that can be used in a car, but at the same time, it's for development to enable. Thank you. To enable development. Well, developers, they only adopt things if they if it's hassle-free, right? No frills. So it needs to be low entry barrier. You need to be able to get easily your hands on this thing. Setup needs to be easy. It has to come with tooling that's easy to understand or is standard, right? That people are known or know already about, and stuff like that. So, I'm a product owner for a while now. So here's my requirements, basically, top-level requirements. So this hardware has to have the capability to go into the car, right? It has to have automotive interfaces, obviously, like a CAN bus, automotive Ethernet bus, GPIOs, for example, for wake-up lines, and whatnot you have in that vehicles, right? And on the other side, you need consumer interfaces, things that developers are willing to use without a huge setup of media converters and whatnot, right? So, for example, having a USB port is like critical, I would say, right? Because if you have USB, you have whatever peripheral you want, even like fans and fancy stuff. So if you have USB, that would be a good deal. Or if you have like consumer Ethernet, meaning like an RG45 plug, right? And not automotive Ethernet, that makes the entry burden pretty low, right? Because you can just attach it to your network and done. Thirdly, it needs to be automotive-grade in a sense. So if you want to have that hardware in an actual car and drive around in, I guess, Death Valley or a desert or something, right, where it's very hot. The other day, you drive around in freezing cold Finland, or a pretty rough road with a lot of vibrations. I think it shouldn't fall apart or go up in flames or something, right? It needs to be kind of industrial-grade thing. At least, or even automotive grade, so that it can actually be used in test cars and stuff like that. And also security-wise, right? If you drive around on public roads or park on public roads, and there is this hardware in it, and which has probably near production certificates and key material and stuff, needs to be stored safely or securely, rather. So that if the car is somehow gone or so, you don't have to be afraid that your key material is in the wild, right? So, and these three things, these three pillars already exclude somehow, well, make the options pretty thin that are out there. And there's a fourth column called open source kind of thing. That's what I would say is, I know I'm at an open source conference, and I like it ideally to be such a reference hardware platform to be open. But that is maybe the pillar where I'm willing to compromise a little bit on. Just a little bit, at least. But I think in the sense of collaborating also on the hardware, I think that should be an open source thing somehow. So how do we do that now, right? You have a spectrum of options if you do hardware. You can make it or buy it or maybe repurpose something that you already have. Repurposing something that you have is not going to work well because these things are typically built for a special use case, a special application, and it will not be easily adopted widely with other partners. And on the other hand, if you try to build this from scratch, like put SSD on it and RAM and flash and whatnot, right? And then you have to go through FCC certification and whatnot because it emits radio signals and whatnot. Oh my goodness, that will be a huge undertaking because doing hardware is not that easy, right? And you have to have the people, and it is a distraction from what we actually want to do. We want to build an SDV core stack, right? So the return on investment will be pretty questionable. And so, yeah, that's probably also not going to make it. And so what is in the middle of that spectrum? In the middle of the spectrum, there's a thing called, and I think that's the best option, at least, system on module, a concept called system on modules. So you can buy off the shelf a module that contains all the hardware heavy lifting, SoC together with RAM, flash, and maybe some connectivity or so. And that's a package you can just buy and be happy. And that's where the heavy lifting is. And the fun part is these modules are out there, and you can have whatever variation of it you want. So it will be like you can have different processor architectures, x86, ARM, maybe RISC-V even. And you can have it with lots of RAM, with less RAM, with much flash, right? And whatever, maybe hardware acceleration units on it, maybe Bluetooth, I don't know, right? What you need, you can probably buy as a hardware module, right? As a SOM. And then, okay, then you have this core of a computer, and you now have to make it like accessible from the outside. And so the idea is you put it on a main board or a carrier board, right? And this carrier board is pretty easy to design, and it integrates your hardware into the context you want to have it in, right? Like like we have automotive interfaces and developer consumer interfaces. That we can do because when we build the main board ourselves, then we can influence that. So the idea is to buy the SOM off the shelf and build the carrier board ourselves. I'll skip over that. Just one word to that. If you have the hardware and you put it in different housings, you can enable different use cases for it, like an on-desk developer desk usage, or a thing that you can screw into a car, or in a lab where you can screw it into a rack, or whatever, right? It's all possible with the same hardware, it's just the housing and like where you put it in to enable all these things. And so Ansgar already alluded to that. Last time I've talked about this, I showed only the screenshots of some preliminary designs we have made, and I just shot the screenshots. Today I'm proud to announce that we have actually put this into a factory and actually built that carrier board. The green thing is our carrier board, right? And the blue thing is just a module that we bought somewhere and put it on it. To be honest, I have no idea if that actually works because it just arrived right before the conference, and I just visited the office, grabbed it, and yeah, off I went to the conference. And so that is also so first thing, we build it, it's there, right? But now the call is probably someone has to review it and make it work. And there's some next steps, like it's not perfect yet. There's, for example, no automotive Ethernet yet on this thing. That would be one thing. Maybe if we want to put this into a car, connect that easily into a car, like OBD connectivity would be nice. So that would be an option to add. But yeah, so I'm not a hardware guy, actually. I can only do software. And this carrier board was built by one of my colleagues, like as a side project, basically. And so we probably need some help to do that, right? And this is basically the reality check now. We have done our first step, right? If the community thinks that it's worthwhile to pursue that path, then let's talk, right? And make this an actual thing. There is stuff there. I am holding it up here, so there is not zero. We are not starting from zero. So maybe there is someone willing to pick it up and work collaboratively on this one. Let's see how that plays out. So very welcome everybody who's wanting to embark on that journey. So last slide, key takeaways as I promised you, and the final kicker thought, right? Yeah, and the test. Sure. The industry is changing into software-first thinking, right? Secondly, we break up functional domains, centralizing functionality, building a common core stack. And I think that a hardware reference platform could serve as the common ground to build this on and to actually efficiently develop such a core stack. We have an example of this here. I would be happy to talk to you if you are willing to take this further. It will enable us to converge to a common stack that serves all these purposes that I've talked about. And here's the clear thought. If we can build our stack on one hardware, if we can agree on one reference hardware, a single thing, then This will make us, like a little bit crazily, design it in the way that we are completely hardware decoupled. Think about it, right? You agree on one reference platform, but you build your stack running on it so that it can run on any platform. Isn't that crazy? And that's because you know when you build the core stack, it won't, in the actual OEM products, it won't run on this thing. It will run on the OEM build hardware, right? And so you have to see that, or anticipate that it will be run on something else. And isn't that what we want in software-defined vehicles all from the beginning, right? It's the prime directive, as I called it, right? We want to decouple from hardware, and I think having a hardware reference platform forces us to do that. So, thank you for your attention. And now attention gets high in this room, right? Now on to the test. Okay, now you were an amazing crowd, so I'm letting off the test. So everything's fine. You can grab your lunch. That's okay. And I think we have a couple of minutes left for questions, maybe. So thank you for being here, and hope to talk to you soon at the conference.
Thank you, Tino. So now we need to figure out where's the folks with soldering skills to put Ethernet or OBD adapters on that. And obviously you need to have your equipment with you. But no, just kidding. Questions? I'm already seeing one.
So I actually have two questions.
Sure.
I have a hardware question and a software question.
Uh-huh.
I'll start with the hardware since it was a hardware presentation. Does Mercedes plan to open source the schematics and the design for that board, or is it a call for action for someone else to build something like that, taking inspiration under NDA to show what they did, and then someone else open source it? For the first hardware question.
Yeah. So easy. Yeah. We can open source that. We can open source put these schematics out there, and I'm hoping someone will pick that up and take it further, right? It's not something that I would see we would do under NDA, because why? We are in an open community here, so let's live that.
Okay, great. Thank you. I hope all the tier ones were paying attention.
Yeah, and I know there's a couple of people around here in organizations at the conference that have electronics divisions, so I'm looking at you.
All right, so for the software question, because you mentioned SCORE there, and I saw the announcement, but there wasn't a lot of details, and it sparked a big interest, right? We talked about it at the TAC before, and so it sounds a lot like a blueprint, right?
Yeah.
So what I want to know is the intention of the SCORE initiative to be assembling other open source projects together into one to create SCORE, or is SCORE a side solution with its own stack?
Now, I think it aims to be the stack, right? And it aims to be a product and not just a blueprint from which you can be inspired to build something. There is a couple of partners that started that project, and all these people are motivated to make that a reality, right? And of course, we are looking for contributions, but we see it as an actual, in the end, it will hopefully be an actual product that will be adopted by OEMs and put into series. At least that's the intention. So let's see how that works out. But yeah, so it's kind of a little bit more than a blueprint, I would say.
And maybe also, since that is public information, anyhow, worth to mention that these partners beside Mercedes is BMW, Corix, Accenture, and ETAS working on that. So the most interesting from my point of view is that there's two OEMs really gearing up to say like, okay, let's agree on what of that middleware we need. We can maybe do together, maintain together, develop together. And that's some interesting development.
Yeah. And I'll it's probably what we will see next year or so in its own talk or something. This is just at the moment it's in proposal stage even, right? So
next year we want to see in Mercedes E-Class and BMW 5 Series with somebody soldering Ethernet and OBD to these boxes and run that stack in those cars. That's the minimum.
So let's talk about that then, I guess.
There has been a question here, and I'm seeing you, Bernard.
Yeah.
Thank you, very, very informative talk. I think Steven asked some of my questions, so I'll just, I'll just add more to it. I see, at least in writing, some initiatives under Eclipse Foundation for open hardware. So would you be considering putting this under such a...
to open hardware and RISC-V is the obvious elephant in the room, I guess. And I'm totally with you on that one. So I would say if there's a connection, then it's like those RISC-V, we could connect with those RISC-V people and have them make a sum, right, that we could put on our carrier board. That would be awesome. I'm not 100% sure, but I think there is RISC-V sums out there. Not 100% sure, but yeah. So that would be the way to connect these the open hardware RISC-V to what I'm proposing. Yeah.
Exactly, yeah, it just fits nice that I can speak afterwards, so representing ARM at the end. So it's interesting for me looking at this, and I clearly see motivation, but the German term, what I see for this, to a certain extent, not take it as a criticism, but at the end it's eierlegende Wollmilchsau. So at the end it's something where you will need to make some trade-offs in order to really use this. At the end you said that you like to have it in production quality, you like to have it as well for prototyping. At the end, in case you like to get time to market, we all know that automotive-grade silicon is not available. You might need to have other silicon from IoT, mobile phone, server side in order to do so. So that's something which I potentially miss based on that. So what is your primary focus at the end? If it's OSS enablement, then of course potentially open source hardware is as well something, but at the end you like to productize it as well because you're an OEM.
Yeah. No, actually, I think that will never be part of our OEM product, like in a car, right? What I want is to build that thing, right? And to enable us as a community to build that thing as efficient as it gets, right? So, and I think one part of the answer how to do that is a hardware platform. If that is exactly that hardware platform and the board that I showed, to be very honest with you, I don't care, right? I really don't. I mean, if we get a hardware reference platform that we can work on, great. If it's that one, even greater than, because then I haven't put the work of my electrical engineer into the trash, basically. But it's not the point that I'm going to. Like, if we settle on something else, great again. But in the end, it needs to serve the purpose of that we build this core stack or this SDV software things around it, and then that we have a playground where we can put it onto and run it in a car, run it in the lab, run it on our development desks, because in the end, the software that we build needs to run, is intended to be in the car. And so just having it run in QEMU is nice, but somehow it will have to run on bare metal somehow at the end of the story.
Yeah, thank you. I have bit one doubt about SDV and hardware, and that is given the experience on a smartphone. So if you say SDV will keep my car for 10 years in an attractive shape because I can always update. And the problem is that more powerful applications require more powerful hardware. So the question is this a design factor for you, for this development, that I can easily change, or a garage can easily change my board and replace it with this plug-in architecture?
Yeah. So this is the power of this system on module concept, because if you need more power, more performance, you just buy a beefier SOM. If you need to check whether your framework for abstracting hardware acceleration works, then yeah, buy a SOM with a hardware accelerator. And then see if your stack works still on this thing. Yes, and buy a second SOM with a different hardware accelerator and see if it still works, right? But yeah, you can do that with this concept. If we would build that just a complete computer and it's just that, you can't place things and play around with it, then yeah, I would be with you and say, well, then we have kind of locked us in with regard to the evolution of the stack and capability.
So we could have additional boards and not only replacing boards, but eventually adding boards.
Yeah, maybe you can even have you can evolve that carrier board into a thing that can carry two SOMs, and you can play some redundancy games, safety capability things there, right? Totally possible.
And the last one, because the others will go into the lunch break, no pressure.
Then I will hurry up. Yeah, partly question between question and remark. I see a very big challenge in maintaining the BSB for the board. And I wonder if there's some plan already, if this should do the community or if this should be run other. Because from my experience, it's a huge effort in the one end, continuous effort, and also legal stuff, because you will need some NDAs with chip suppliers for your baseboard, etc. Maybe this is something that the foundation could take over. Like I think Raspberry Pi is doing the same with the foundation that takes NDA drivers, build binaries that are able to release. So this is some, I think, very challenging piece here. Is there a plan already thought, or is this something we need to talk about in the future?
Yeah, I would say there is some vendors out there that also deliver open source BSPs for their SOMs, or some of their SOMs at least. And if we just discussed RISC-V, so maybe that would be a route where you could go, and well, then we have it all open anyway. And I would hope then, if we get the RISC-V guys motivated to build such a SOM, also provide a board support package for that that we can use, right? And I learned that we will have connections to QNX in the future, so maybe we can do something there as well. So.
All right, then thank you, Thilo, for that interesting talk on hardware on a software conference. Thanks to all of your questions. This is now first one hand of applause for Thilo. Thank you. There you go.
Thank you.